In the previous video, I talked about a lot about expected value, where expected value is the amount we are expecting based on the net amount of gain and loss, and the probabilities that determine this net amount, right? So then we have this equation right here, x1 times p1 plus x2 times p2, all the way to xn times p of n. We went through an example through rolling a dice and me winning the amount of money depending on how I roll, finding the expected value being I kind of win. We're now going to move on to a new topic called independent and dependent events. In this way, this is going to help us find more probabilities. So this is going to find more probabilities. And the reason why we're going to do this in the first place is because when we find these probabilities, right? So if I recall, probability is going to equal to the number we want over the total. So when we think about the total amount of outcomes, and probability is not just always just one singular event, but rather it can be a multitude of events. So as an example, and I'll kind of cover the definitions that I have, but an example of a multiple event is, let's say, poker, right? So in poker, I'm always depending on multiple cards that I have, right? So I think for poker, you just have two cards. So in that case, you're just depending on the dealer's card. So basically, the way that poker works is that you have basically two cards to start off with. So this is you, right? So let's say you have a 2 and then a 3, right? To get maybe a straight. And then the dealer provides, I don't know, something like this. 1, 2, and then has basically 3 cards. And then you keep on betting, but then the moment that they do the next card, so let's say I had that, right? So I think for poker, I think it might be 4 or 5 cards, I'm not too sure. But let's just say it was going to be 5 cards, right? So this red card first represents the first event, right? The probability of us getting some kind of combo based on these 4 cards so far. Then the dealer brings in another card, and this is the second event. And this second event can definitely play a hand with when you're playing poker, right? Because with the first and second event, if there are good cards for your combo, then you would basically bet in the right place, depending on how you play it, right? So this is why when you notice with the first and second event, these are multiple events. And we were talking about this before, right? There's multiple events that can happen. In many cases, like rolling maybe a 1, 2, or 3, and there's different ways that we can think of it like that. So let's talk about what independent and dependent are. Independent events is when event A is not affected by another event B. And a dependent event is when event A is affected by event B. So let's come up with an example for both. So for independent, the simplest one that I can do is flipping 2 coins. So the reason why this is going to be an independent event is because when I flip one coin, when I flip the first, I'm going to say flipping the first does not affect the second. And that makes sense, right? Because when I flip a coin, when I flip the first coin, it doesn't affect the flip of the second coin, right? The second coin still has 2 outcomes. It does not affect the second coin. Because for the first one, that one has 2 outcomes. So does the second coin, right? I didn't affect it in any way, so we still have 2 outcomes with that. Let's think of another one. Another example could be, let's say, as an independent event, 2 super random ones, right? So let's just say I drew a card in a deck and rolled the dice. So you can definitely tell that this is a very independent event, because if I drew a card, it has no effect on rolling a dice, right? But then this is where it gets a little bit complicated. So now let's think about examples for a dependent event. So for dependent event, we have to figure out when one event does affect the other. One common example that we can do is basically drawing a card, drawing multiple cards in a deck. Why is this? Well, it's because when I draw one card out of the deck, that probability is going to be 1 over 52, right? That's just one card out of the 52 cards. So I'm going to label this as the first card. But then for the second card, when I draw that one, the numerator is still going to be 1, but then the denominator is going to be 51. Why? Well, it's because I took a card out. Because I took a card out of my 52 cards, I'm left with only 51 in the deck. Heck, if I even did the third card, the probability of me getting that is still 1, but now it's become 50. I took another card out. And then for the fourth one, it's going to end up being 1 over 49. So we can see that the probabilities are different from one another, because when we take one card out, it does affect the next card. Here's another one. Let's say I just drew marbles out of a bag without replacement. Replacement means I don't put it back. So if I have like this bag, right? And then I have a bunch of marbles right here. So let's say that's 6 of them. If I took one out, the first one is going to be 1 out of 6. But then now, let's say I just took another one out, right? If I took another one out, just erased it. For the second one, now I have less marbles to get out, 1 out of 5. So notice that this is what independent events are. They affect one another. So let's do some practice problems, right? So practice. So let's say for one, we have to determine if it's independent or dependent. So for the first one, let's just say that I'm going to roll 2 dice. Okay, the second problem, let's just say I'm going to do a raffle. Do a raffle for 3 winners, let's say that. Then the last one, I'm going to say drawing a card from a deck with replacement. Okay, so just take a couple of seconds to think about that. But think this is not going to be too hard. Just think about if one of the events is going to affect the other, and then that'll determine if it's independent and dependent. Okay, let's go over this. So if I roll 2 dice, this is going to be an independent event, because the first dice does not affect doesn't affect the second. And that makes sense, right? When I roll a dice, usually in a game, it doesn't really affect the second one. It affects the sum, but it doesn't affect the actual second dice. If I do a raffle for 3 winners, this is going to be dependent. And then why? Well, it's because we remove a ticket for every winner. So when I remove a card, there'll be less people that are going to be in that box. So then my chances are supposedly a little bit higher, but I mean, it's not going to be that much. But hey, hey, it'll improve our situation. And then the last one is drawing a card from a deck with replacement. So for this one, since it says with replacement, we have to think about this. If I draw a card, if I say like the first one, that's going to be 1 out of 52. And then what about the second card? I still said it's 1 over something, but since we're taking out the card and then with replacement, that means we're putting it back. So that's still going to remain to have 52 cards in the end. And heck, even after the third card, we put the second card back to get 1 out of 52. Same thing with the fourth. We get 1 out of 52. So that's why it is going to be independent. So yeah, this is basically just a short summary of what it means to be independent and dependent events. Independent is where A is not affected by another B. Dependent, whereas A is affected by another called B.